This week we'll be talking about 2D shapes and lines of symmetry. This is our third and final week of our geometry unit. When we're talking about 2D shapes this year, we really want to focus on the definition of the shape and not just what it looks like, because we'll be classifying shapes based on how many sets of parallel or perpendicular lines, how many acute, obtuse, or right angles, or if they have congruent sides or angles. Congruent meaning same size, same shape. So if they have two sides that are the same length or something like that. Okay, so let's get started with a polygon. Polygons are shapes that are closed figures with all straight sides. That means no curves, and that means no openings. So you have to have at least 3 sides to make a polygon, because you can't have a closed figure with only 2 sides. And so it has to be closed and it has to be straight. Here are some examples. Triangle, quadrilateral, specifically a square, pentagon, hexagon, heptagon. Sometimes a heptagon is also called a septagon, by the way, a 7-sided shape. Octagon, nonagon, decagon. And you really don't need to know past an octagon. So there's a bunch of different polygons that we're going to be talking about specifically. Remember, if it has curves or it's not closed, it is not a polygon. So a heart or a circle is not a polygon. But they don't have to be just regular figures and just have to be like squares or triangles or whatever. They can just be random shapes like you see these blue ones at the bottom, as long as they have straight edges and are closed figures. So within that category of polygon, we're going to be talking about other categories such as a quadrilateral. And when I look at this word, I want to focus on this prefix here, quad, and that means 4. You can think like a quartet is 4 musicians. You could think about like a quadriplegic doesn't have the ability to move any of their 4 limbs. You could think about a quadrant is like fourths, kind of like a quarter. And so these are any shapes that have 4 sides. It's a polygon that has 4 sides. And here you can see a bunch of examples. They don't have to be a regular shape like a square. They could also be something, I've never known this to be a dart, but that's a cool name, or a trapezoid, kite, parallelogram, rhombus, rectangle, any 4-sided polygon. Next, we've got parallelogram. And a parallelogram is a quadrilateral. So by the time we get to parallelogram, we know it's a polygon, it's a quadrilateral, it's a polygon, right? So we know it's closed, and we know it has 4 shapes because it's a quadrilateral. We're going to add another rule to its definition. It has 2 pairs or 2 sets of parallel lines. Remember, when you're thinking about parallel lines, I always think about the 2 L's in parallel. They're never going to touch and go forever in both directions. So what we're going to do here is look at opposite sides of a shape and see, are these parallel? So if I look at this rhombus here, these sides are never going to touch. That's one set, right? The second set would be the other 2. That boom, boom. Those 2 lines is a second set, 2 sets or 2 pairs. If I look at a rectangle, the top and the bottom are parallel, but also the 2 sides are never going to touch. They're parallel. So that's 2 sets of parallel lines. Lastly, a square, which we know is a special type of rectangle, the top and bottom are parallel and the sides are parallel as well. A square is another type of quadrilateral. It's also a polygon like we just saw because it has the top and the bottom are parallel and the sides are parallel. So a square is an example of a polygon. It is an example of a quadrilateral. It is an example of a parallelogram. What's special about a square is that it has 4 congruent sides. That means all four sides are the same length. Now, in math, we have these little mathematician symbols, right? When I look at this square over here, I see that it has the little right angles in there. Anytime we see that box, that means right angles. And so this square has 4 right angles. Every square has 4 right angles. It's part of the definition. These little lines here, there's one line on each, and that means that each side is the same length. So we know it's a square because all 4 sides are the same length, and it has 4 right angles. Now a rectangle is similar to a square, right? It is also a polygon. It is also a quadrilateral, 4 sides. It is also a parallelogram, 2 sets of parallel sides. What's special about a rectangle? The definition of a rectangle is a 4-sided shape where the top and the bottom are parallel and the same length, right? It has 2 sides that are the same length, and the opposite sides are the same length. And then these sides are also opposites. They're parallel and they're equal. And if we think back to our little fancy math symbols, we see this one and this one have one line. That's a way to say these two are the same, whereas this side has 2 lines and this side has 2 lines. That's because those two are the same. Okay, so that's a symbol that says opposite sides are equal. Now, if we look at a square and think about, is this a rectangle? The answer is yes. I know you guys know that. A square is a special type of rectangle. Because a rectangle must have 4 right angles. We know a square has 4 right angles. And a rectangle must have opposite sides that are equal. Are the top and bottom equal? Yes. Are the sides equal? Yes. So just like any other rectangle, it has 4 right angles and opposite sides are equal. I can do the same thing here. 4 right angles. Are the top and bottom congruent or the same length? Yes. Are the sides congruent or the same length? Yes. Opposite sides are equal and it has 4 right angles, so a square is a special type of rectangle. The remainder of this PowerPoint will be talking about lines of symmetry. Okay, a line of symmetry is a line that divides a shape into 2 parts that could lay on top of the other identically. That means if I folded this shape in half down a line, would it look exactly the same on both sides? So it divides the shape into 2 congruent or same size, same shape parts. When we're looking for lines of symmetry, we might see a vertical, an up and down line, or horizontal side to side line, or a diagonal line of symmetry, and that means it crosses. Okay, so let's look at our examples. If this little bear here, if I tried to draw a line horizontally, that bear would not match up. But if I tried to draw a line vertically right down the middle of that bear, it would line up perfectly, right? His cute little smile, his cute little eyeballs, his cute little arms and feet would match up and it would lay on top of each other if you could fold that picture in half. If I look at our butterfly, a vertical line of symmetry, his eyeballs would match up. His little smile would fold onto the other part. These would match up. The wings would match up. So that's a horizontal line of, a vertical line of symmetry. So these guys both have one line of symmetry. If I go to this little goldfish and cut it horizontally, okay, at first glance, it seems like, yes, the shape of the goldfish would line up. However, it would not quite work because is there a matching smile on the other half that would line up perfect? No. So that means there is not a horizontal line here. And just for kicks, if I draw a vertical line, does that work? No. What about a diagonal? No. So this one has 0 lines of symmetry. Let's go to this computer. All right. I can see if I draw a line right down the middle horizontally, I have the monitor on the top and the keyboard on the bottom. Those aren't exactly the same, so that's not going to work. What if I go vertically? Yes, that's one line of symmetry. Last one, this present, this is really close to symmetrical. However, when I draw a line, are these ribbons going to perfectly match? I don't think so. They've got a different angle. So this is also going to be 0 lines of symmetry. All right, and there we go. That's what we said too. All right, let's kick it up a notch. Let's draw lines of symmetry on this shape. So if I'm looking at this first one, and if I draw a line right here, would that diagonal line cut it in half perfectly? If I folded that, this part of the arrow would match up here. This part of the arrow would match up with this one. So this is a line of symmetry. Now, what if I cut it the other way? Would that work? That would also work. So far, 2 lines of symmetry. But if I drew a vertical line, that is not a line of symmetry. So I'm going to write 2, and I'm going to erase that diagonal one because that would not work. Let's go to the next shape. If I drew a vertical, is there a vertical line of symmetry? Yes, that would fold perfectly on itself. What about horizontal? Yes. What about diagonal? Not quite, because this shape is going to come like if you think about if there was a mirror, it would like mirror over here. And so that's not going to work. So I'm going to go ahead and erase the diagonal, and then that would give us 2 lines of symmetry as well. Okay, next, I try vertical. Well, I'm trying to draw it, but it's pretty bad. But yes. Horizontal, yes. Diagonal, yes. Other diagonal, yes. So this one has 4 lines of symmetry. And you could have a shape with infinite 20 lines of symmetry. But you'll probably see for these, you won't see more than 6 or something. Okay, now if I draw a vertical line, would that line up perfectly? This guy doesn't have a little counterpart over here, so vertical does not work. Let's try horizontal. If I drew a horizontal line, would that line up? Yes, so I'm going to give him a 1. Awesome, and there's a clean version of what I was doing. We'll also see a lot of letters in symmetry. Here we go again. We see vertical, horizontal, or both, or sometimes there's none. So the letter S, a lot of people, it seems like it would be symmetrical. But if I cut it across like this curve right here would be here, right? It would curve around this way. So it looks symmetrical, but it's really not. So this is a no. What about a T? Well, horizontal wouldn't work, but if I cut up and down, those are perfectly on each side. So this is a yes. N. This is another tricky one. If I cut it here, remember that this part is on the bottom and this part's on the top, so they're not going to line up because it would be like something like this. And I recommend just cutting these out and trying it. An N is going to be a no. N for no symmetry. Z. This is another tricky one. It seems like it would have a horizontal line of symmetry, but this is also a no. M. I see a vertical line. So yes, this has a line of symmetry, but no horizontal or diagonal. Exit ticket. Draw lines of symmetry, pause, and play to get your answer. I have 1 line of symmetry on the frog and 4 lines of symmetry on the square.